factoring a trinomial. For a 3-terms polynomial, trinomial, we have to decide whether it is a perfect square or it's not the perfect square. If it is perfect square trinomial, then we have x plus y squared, or x minus y squared. We have a formula for that. X plus y squared would be x squared plus 2xy plus y squared. If you recall, we verified that last time. We had, I can get my pen back here. Here we have x plus y squared. This would be the same as x plus y times x plus y. That would be when you have this binomial perfectly squared. Yeah, when we have x plus y squared. So if I use the FOIL method, multiply this term by term, x times x give me x squared, x times y, they give me plus xy, and I multiply the 2 furthest term and 2 closest term, I get the same exact term, xy. And then if I multiply the last terms together, I get plus y squared. Okay. Notice that these middle terms always add up to 2xy. That's why we have this 2xy here. So if it is perfect square, then we have x plus y squared, then we have this form here. The first term squared plus 2xy plus the second term squared. If this were minus, both of these would be minus, and the only difference would be you would get minus 2ab instead of plus 2ab. Middle term would be minus 2ab. So if you can recognize this, you can factor this polynomial this way. Let's take a look at the example. Here we have 16m to the power of 2 plus 56m plus 49. Okay, this is, if you can recognize this is perfectly squared, then we can factor these as 4m plus 7 squared. Now if you didn't recognize this is perfectly squared, we can open 2 parentheses and use the method we learned last time. Look at the first term here. The possibility for 16m squared would be 1 and 16, 4 and 4. So I'm going to put 4m here. If I put 4m here and 4m here, and if I look at the constant 49, the possibility for 49 would be 1 and 49, 7 and 7. If I put 7 and 7 here, you'll see that if I multiply the 2 closest term and 2 furthest term, 28m, you see you get add up to 56m. And then both has to be positive, of course. So you can see that this is a perfect square trinomial. So not recognizing if it is perfect square trinomial, it's okay. You still can factor it using the trial and error method that you learned previously. Let's take a look at the second part here. 8t squared minus 13t plus 5. So in this case, we don't have perfect square trinomial here, as you see. So we can use our trial and error method that we learned as well. So let's do that. If I open 2 parentheses here, look at 8t squared. Well, for t squared, obviously it's t and t here. For 8, I can use 1 and 8, 2 and 4. Okay, if I use 8 and 1 here and look at this 5, there's only one possibility for 5 here, would be 1 and 5. So if I put 5 here and 1 here, if I multiply the 2 closest term and 2 furthest term, I can see that I can come up with 13t, minus 13t. Here I give me 5t here, and that give me 8t here. So if both of them are minus, then I can make 13t out of that. And then you always want to check the last term. Minus 5 times minus 1 is equal to plus 5. Everything is correct. Sign is positive. And that's one way we looked at how to factor last time. You can use that. Or we can use the other method we learned to break that negative 13 to minus 5 and 8 and use factor by grouping the results into the same factoring. We looked at both methods last time. So as you see, this one here is not perfect square trinomial, but this one is. We used a trial and error method to factor both of them. Take a look at another example here. We have 6x squared minus 3x minus 63. If you look at carefully, you have the first step was to see if we have anything in common among all these, and we do have 3. The greatest common factor among all these terms would be 3 here. If I factor the 3 out, then I get what times 3 give me the first term is 2x squared. What times the greatest common factor give me the second term is minus x. What times 3 give me the last term would be minus 21. You notice that again, if I distribute this, I get back to what I was originally had here. So now we can factor this. We want to factor completely. So we can again use the method that we learned earlier, or we can use the trial and error method. We can open 2 parentheses here for factoring this. You look at the first term. This is 2x squared. Well, x squared would be x and x. And 2, the only possibility would be 2 and 1. I'm going to put 2 here and 1 here. And then look at the last term, minus 21. The possibility for 21 would be 1 and 21. 3 and 7. Keep in mind that when you multiply the 2 closest term and 2 furthest term here, you want to make minus 1 here. We looked at this method last time. If I were going to pick, let's say if I put 3 here and 7 here, and if I multiply the 2 closest term, I get 3x here, I give 14x here. Can I make minus 1 out of this? Obviously not, right? I cannot do that. So in order to see if the other possibility works, I should switch the position of these. I can do that. And then see, now that works. Here I would get 7x instead of 3. And then here I would get 2 times 3 would be 6x. I can have minus 1 if I have 7 to be minus and plus 6 here. So that would make this 7 minus and this is plus. So you can use the trial and error method, and when you do that, sometimes you have to switch these terms around in order to find the right combination, or again use this other method here and use factor by grouping. As you see, we get the same results here.